Good afternoon, and thank you very much for allowing the time to join us today. My name is Charles Scott. Welcome to this month's Civil Designer Software Open Classroom webinar, number 87 in this series. If you're new to our webinar series, please visit our website, www.civildesigner.com, go to the Services pull-down menu, and click on the webinars link to access our library of past webinars. Or, under the same Services pull-down menu, click on the FAQ video link to access our library of 550 short, searchable videos created from this series by typing your topic of interest in the search bar, be it how Civil Designer interacts with Google Earth, or Civil Designer's 3D rendering tools. And finally, while here, please visit our BIM page, where we list the many ways Civil Designer proficiently contributes to any BIM workflow process, which includes packages like Allplan, BIM 360, BIM Vision, Bentley, and Revit via a standard 3D DWG, a 3D DWG using a shared reference point, a dynamically linked Civil Designer model, and via a range of IFC files created in Civil Designer exportable to packages like Allplan, Bentley, and Revit, amongst many others. Back to today's webinar, where I'm going to be joined by Andrew Cole, who will be covering our road regression or rehabilitation functionality using the latest version of Civil Designer, version 8.5 Build 11. During Andrew's presentation today, please feel free to use the text chat service on your GoToWebinar app or web page to ask us any questions you may have during this time. Andrew, it's been great working with you again. Please take it away.
Thanks, Charles, and welcome everyone to this month's Civil Designer Open Classroom. In today's session, we're going to be looking at the Civil Designer regression tool, so the extract alignments and extract strings in a bit more detail. And then I'm also going to have a look at the area volume automatic optimize, manual optimization. And when editing those cross sections, if you recall, I have covered that in a previous webinar where you do the manual optimization in the cross-section editor. So let's have a look at that. We go section graphical edit. You could, in this toolbar on the left here, you can click on this move section button over there on the toolbar, and then you can set a base layer that you're moving relative to. Click on your screen, and then you can change your design cross-section. And wherever you position it vertically, the template, the current template at that change would be applied. Okay, so that's the optimize inside this graphical edit window. And when you're editing these cross-sections, as we are doing over here in the cross-section, we're using the automatic optimize, which automatically would optimize. And the way that works, it moves your cross-section, your center line as close as possible to your natural ground over there. Okay, so the automatic optimize basically takes each cross-section, moves it closer to your NGL. So just to confirm that these cross-sections, if you go and make changes to them and you don't reapply your template, then the volume calculations would be based on these edited cross-sections. And the vertical alignment that you might have had before the time hasn't been applied to these cross-sections. So your cross-section basically won't be following your vertical alignment if you manually edited the cross-sections or use that automatic optimize function. So what I'll look at today then is the way to get back from these manually edited or the automatically optimized cross-sections and get back to a vertical alignment. So you would have used the optimize, that automatic optimize, to balance the cut and fill on your road cross sections. And then you can use the regression, extract alignments, to once again extract your vertical alignment and fit it as close as possible to the revised cross sections, to the cross sections now where they are vertically positioned after the automatic optimize. Okay, but I'll show you how that works. So that's what I'm going to look at first, is that automatic optimize. Let me just escape out of here. I'm going to page down. I won't save the changes. Let me just show you. So we're going to look at this. You can see in the plan view over here, this is where we are. And then we're in quite a bit of cut in that section of the road. Okay, when we run the area volume, that automatic optimize, the program is going to move your design layer, as I mentioned earlier, closer to your ground line. And it's going to be balancing the cut and fill volumes. So what we should first have a look at then is the mass fill volume. Let's have a look at the pre-optimize mass fill volume. So I'm not going to do topsoil or compaction. We'll just do a quick calculation. See those cross-sectional areas being calculated. We also run the junctions that fit into that road, tie into the main road. Currently selected, you can see over here, doing the volume separately for the junction. Okay, so let's have a look. The main road, so not the junction portions. So just for the main road, the end area calculations, we've got about 335,000 cubes of cut, 183,000 cubes of fill. Okay, so that's pre-automatic optimize. I'll just keep a record of that. Okay, so let's run that area volume, the automatic optimize. The manual optimize, pretty much the same as the graphical method we looked at earlier when we go into our cross sections. So the same as this move option. With the manual optimize, we give you an option to move with your arrow keys. You can use the up arrow and specify a distance, for example. Okay, so that's just an alternative with the manual optimize. Okay, let me just page down. I won't save that section for now. I'm just going to close that. So that was the manual optimize. Okay. In this case, we want to look at the automatic optimize to balance the cut and fill volumes per cross section. This is that preview time, so I've set that so we can view each cross section 20 milliseconds. Still going to be relatively quick. And then you've got two options when you run this optimization as far as applying your template goes. So you can apply your existing template, or you can apply specified batter slopes. So in the next dialog, you'd be able to specify your batter slopes. So let's just apply the template. If you are using that batter option, then you need at least 3 points in your design cross section. So you would need your alignment, centerline point, and then at least the 2 road edges. So if you're just putting in a horizontal alignment, generate your edge levels, and then you should have enough points to run just new batter slopes. But in this case, we're going to apply a template to these modified cross sections or optimized cross sections. Okay, and then topsoil stripping, zero that for now. And then this is the tolerance between the cut and fill on each cross section. So let's leave it at 20% is fine. Okay. And you can see it's relatively quick, but you can see the design cross section is getting very close to your original ground, your natural ground cross section. Okay, so let's go have a look at those cross sections, graphical edit in this area again. This area where we were quite deep in cut, that has now been updated. We're pretty much very close to the ground over here. Alright, but the test will be if we go and have a look at the volumes here. Let's just run that area volume now. Mass or volume. So these volumes are calculated based on your current cross sections, those ones we just looked at. So calculate that using the same settings. You can see those cross sections, the design cross section has been moved a lot closer to your natural ground. Results to output. That standard procedure of ours to select the results to output. Okay, so here we go. Unadjusted volumes is what I'm looking at. So from 335,000 we're down to 76,000 cubes in cut and 81,000 in full. So you can see the cut and full has been balanced out pretty closely within that 20% tolerance. Okay, I'll just run it again, that area volume and automatic optimize. And what I'll do this time, let's have a look at the batter option here, just to show you the settings that you get with the batter option. So as I mentioned, you get to set new batter slopes to the modified cross sections. So your left cut and full, right cut and full, adjusted slopes, batter slopes that you can set. And then you can also set a minimum bank length. So the distance either from your center line or from the shoulder break points of your cross section, the minimum length that bank has to run. So similar to the road templates, that min max condition that you can set, in this case it's a minimum distance. So the bank has to run a certain distance, at least that far. And the bank slope will then be adjusted to meet the ground at that distance. Okay, I won't run it now. Okay, let's go plot a few cross sections. I'll just do from, let's go 3000, just in that section where we had that deep cut, just every 20 meters. Just look at those cross sections. Okay, so you can see the deep cut has been done away with, and we pretty much optimized all those cross sections. You can actually plot those a little bit wider if you wanted to see a little bit more. Just the offset here, say 50, negative 50 meters to the left, 50 to the right. Kind of slightly wider cross sections. You can see your toe lines. Okay, so I just viewed the cross sections so you can see currently that is what the program is going to use to plot cross sections and then to calculate your road volumes currently until you go and reapply your template again to this design. Okay, so those are the optimized cross sections, but how do we tie that in with the vertical alignment? So currently, I'll look at the vertical alignment. The red line being my vertical alignment. You can see there's the green line, your natural ground. But if you want to view those cross sections, let's go switch that on. Activating another ground line over here. From the cross sections, it's got to be my layer 2, road cross section layer 2. Just going to change that color so we can see it. Okay, so remember, green is the natural ground. The blue line now represents the cross sections at every 20 meters, whatever our chainage interval is. The red line is the current vertical alignment. So if you still want to then go and use your vertical to do design criteria checks, that sort of thing, then we're going to have to adjust the vertical alignment to move a bit closer to your newly modified or optimized cross section. So we want to actually tie those two lines in a bit closer together. So there are two ways to do that. The one would be to actually physically go and change your vertical alignment. So just a normal right click, move PI, or delete PIs, insert PIs where necessary, just to get it to run a lot closer to the blue line. Okay, and then the alternative, the more automated way, would be to use that regression tool. Just checking this, there's quite a big gap here. You might think, why isn't the blue line a lot closer to your green natural ground line? We just look at the cross sections in that area, see what that chainage is, about 3080. Okay, so this cross section, I'm just going to use that G shortcut to go to, so in that area over there, I just have to make this the active dialog. We remember we're optimizing to 20% balance between cut and fill. And because that's quite a deep fill over there, a deep cut, so the program had to adjust for that. So in this case, the cross section line, the blue line, is a bit lower than your natural ground over there. But generally with that optimize, if it's relatively flattish ground, then it'll move it a lot closer to the center, the natural ground at the center line. What we're going to do then is we're going to use that regression method. So as I said, you can do the manual method. So physically go in here, move your PIs, just try and get it a lot closer to the blue cross-section line, the current optimized cross-section line. But the vertical regression is going to go and redo the vertical alignment and try and fit it along our cross-sections. Okay, so let's go have a look at that alignment regression, extract alignment. So we're going to use the extract alignments. The difference between the extract strings and extract alignments, with extract alignments, you're actually going to be picking up a horizontal alignment that can be edited and a vertical alignment that can be edited. So in this case, we're looking at the vertical alignment. And we're extracting the regression data from the cross-section. So it's our layer 2 final road cross-section layer, the optimized cross-sections that we just performed earlier. Okay, you can set some tolerances, how close you want the vertical alignment to be to that cross-section layer, and a rounding on your vertical curves. Okay, and then this is to extract your ground cross sections. So we're extracting from original ground, storing that would go to road layer 1. Okay, we don't need to extract pivot lines, that would be for dual carriageway. Okay. Okay, so it's run through the regression, and you can view the output window for any possible errors. I'm just going to go straight to that alignment, vertical, edit alignment, and have a look at the the new vertical alignment. Okay, so I'm kind of interested in this section here. So you can see these are all the new vertical PIs. So the program is trying to fit the vertical alignment as close as possible to your cross sections, those optimized cross sections. Okay, so that's basically the quickest and easiest way to get your vertical alignment to follow those optimized cross sections, but it would require that you do some editing, some tweaking on that vertical alignment, especially if you're trying to smooth it out as best as possible, switching off those VPI names. And if you need to also then make sure that you're meeting certain design criteria for your vertical alignment. Okay, so I'm finished with this optimized project, and I'm going to move on to this road rehabilitation project. For those of you that have watched our previous webinars or looked at our FAQ page on the civildesigner.com website or our YouTube channel, would have noticed that we've got quite a few videos on the regression functionality, but this particular project was quite unique in that there was a combination of the various extract alignments and extract strings functionality, or a combination of the two, that was used in this particular project. So I thought it would be useful to share that with you. Okay, so what I'm going to do, I'm going to run through this design basically from start to end, the rehabilitation, just to run through these steps again. And then we'll just touch on that unique sort of combination of using the extract alignments and extract strings to get the actual final design done. Okay, the other reason that I wanted to use this project was that I have used it in a previous webinar, one of those section editing webinars. And if you recall, for those of you that might have watched that, we had a couple of cross sections where we picked up 0 elevations with the extract strings, and I had to go and fix those in the enter edit. But you might have been wondering why this center point of the road, or those cross sections, was a lot lower than the road edges. So the road edges were picked up with the extract string, so they've been heightened and interpolated from the survey, the surface of the natural ground, or the existing road in this case. And then the center line over here is actually from the vertical alignment, so from an actual vertical alignment. Okay, so the vertical alignment for this road project would then obviously need to be revised so that everything ties in correctly. And in fact, this project that we're going to look at next, the rehabilitation project, the reason for the two combination of the extract strings, extract alignment, is due to low spots on the road. We'll have a look at fixing that. Okay, so let's go back there. We're going to run through this project from start to finish. I'm just going to start off by copying my NGL. So this would be my surveyed road surface 1, okay, NGL, which is in fact the survey of the road. I'm just going to copy that. So I'm just going to go to our survey application. I'm just going to make a duplicate. So duplicate surface. I'm just going to put it on surface 3 for now. Okay, so the reason that I'm keeping that is that I want to keep the original survey intact. So I'm just going to work on the copy. So I'm just going to my display settings. I'm going to go to the surfaces. And in fact, I can switch everything inactive, hidden, lines off, and then just switch on that surface 3. Just going to rename that. That's the copy of the NGL. Okay. Okay, for this particular road rehabilitation project, we need the edge of road points. So we're going to use this name filter just to display the points that define the road edges. So those are the two. I've already set them up. You can set your filter just S to refresh. Okay, so these points have already been linked up with break lines, but we need to check that these lines are connected. So basically what I want to do is I want to define a CAD line, and the way I'm going to do that is I'm going to use the strings, the terrain strings. I'm going to create a string, a point string, which joins up points and the break lines. The alternatives, we've looked at that in previous webinars where you can use the draft expert, for example, in combination with IntelliLines. You can draw in these lines, but in this case the triangulation has already been done, so I'm going to use a terrain string. But you need to now zoom through and just check these lines. So for example over here, let me just go to the terrain application. I'm going to go and add a break line. We can use the toolbar, add a break line. So basically from there I'm going to go across to there. Okay, so the way this point string works, it's going to track from a start point, DTM point, along the break line until the break line stops. So you can't have lines linked together here. So that's why I've created a separate surface, and I can now go and delete these break lines over here. In fact, there's one over there. Okay. So you're going to have to tidy this up so that the point string just runs continuously from the start of this road edge right through to the end. Okay, I've pretty much tidied it up before the time, but for example over here, I need to remove that break line. This one, just see, that's fine. So I've got a copy of this surface, so I can just run through from there to there. Okay, so just tidying it up. I've done a bit of work on this before the time, so I just want to run through it quickly. Okay, this one we still need to do. So there's a couple of lines here I need to delete. That one. And then I must also do these lines over here. So you just have to break it so that when it runs from the start to the end, it's just one continuous line. Okay, so there we go. That looks fine. I've tidied that up already. I did a bit of work before the time. Okay, and then yeah, there are a few I need to tidy up as well. You can also use our remove crossing lines feature, that new function. So it's model break lines remove crossing. So this would be surface 3, and then you can just draw from one point to another. A bit quicker working like that. The test for this would be when you actually run the point string to see that it runs from the start to the end point. I think there is a bit of a problem. Let me just go and zoom in there a bit so I can go delete those lines. Still using that remove crossing method over there. I think I'm pretty much done with this whole road now. Okay. Alright, so zoom all. Okay, so now we want to put in the CAD line for the road edges. We're going to use that for our regression, the road edges that we want to pick up. But we also need to firstly create the CAD line. So the way I'm going to do it is with a terrain point string. So it's this string creation and a string from a point string. So that's the DTM points and the break lines that are joining. It's going to track all along the break line from start to end. Okay, so this one I'm actually going to start on this top end. So I'm calling that the left edge. I'm working from left to right on my road. So I think the alignment would be from left to right. Okay. And the test is, does the string run right to the start of the road here? And yes, it does. So that's good. So we're good on that edge. The other one I'll do, so it's creating another string, terrain string from the point data. I'll run this one from this side. I'm going to call that right edge. I think the road alignment starts on this side, so we'll call that right edge. Let's see how far that ran. Okay, so that didn't run all the way, so somehow there's a problem here. I'm just going to select that one and delete it. And you can actually see what the problem is. There's a line running from there to there and then from here to there. Okay, so in this case, it's just something you have to be aware of. So I can go remove that break line. So that one was running right through. Okay. Sometimes it's easier just to delete all the break lines and then just add a new one. Okay, so hopefully that was the only issue. Let's try it again. So we're going to do the string creation again. String from point string. Just zoom in at the start there. Okay, what we're calling that right edge. So let's see how far this terrain point string goes. See if it makes it to the end. Doesn't look like it. Let's see, there's additional line over here that I forgot to remove. Hopefully that's the last one. Let me just delete that break line over there. Somehow missed that. Third time lucky on this side, let's see. So it's string creation, string from point string. Call that right edge. That's good. So it's running right through to the end. Okay, so I'm happy with that. And I can just file save my project at this stage. Okay, so we've got the two road edge lines. In fact, at the moment, they are terrain strings, so I'd need to go to the CAD and explode those. So exploding the terrain strings would then make them into polylines. Okay. And then I just want to, at the start of the road, we want the road to start on a straight. So I'm actually going to go remove some of these vertices in the polyline. And then I want to move that one to there. Again, the same, so deselect, move some of these vertices. Okay. So there we've got the polylines that we need for the road edges. Okay, so now we can go to our roads application. I'm going to select a road file to work with. Just add a road file. Okay, so just naming the road. Okay, the actual alignment for this road I'm going to have to bring in just to save a bit of time. So this alignment, I'm just reading it in from a CSV file. There it is, the horizontal alignment. This was done with the regression that extract alignments using control points. So 2 points on a straight, 1 on a curve. But just to save time now, I've brought it in like this. Okay, just check my road expert. I've disabled that. Okay, so we've got an alignment. I can just coordinate that quickly. Let's go horizontal coordinate. Let's go make that smaller. Okay, and then I just want to extract some ground cross sections. Let's use the NGL. Which in fact was the survey of the existing road. Okay, let me just change these polylines are border line type. I just want them to be displaying a bit better, so make those continuous. Okay, and then what we want to do is we want to run the road, the regression. I'm going to pick up the vertical alignment. So I've got a horizontal coordinated extracted cross sections. I'm going to use the extract alignments and the vertical alignment. So this would allow you to tweak your vertical alignment. If you're using the extraction of the horizontal vertical, you get an actual horizontal and vertical alignment that you can edit, which you don't get with the extract strings regression method. Okay. Okay, so that's put a vertical alignment all along that road of ours. So let's have a look at that. Pretty much drapes the vertical alignment all along the road. Okay. I'm just going to switch off, let's switch off those high and low points for now. Okay, so I'm happy with the vertical alignment. Okay, so now I want to pick up the road edges. So for that, I'm going to use the alignment regression extract strings. Okay, in extract alignments, we do have road edges from CAD, which positions them in the plan view at a horizontal offset, but it doesn't position them vertically. So I'm going to use the alignment regression extract strings. Okay, we're going to pick up the left edge string and the right edge string. Okay, and we're going to be interpolating on a DTM surface. Okay, I'm just going to make that one surface 1. Okay, which is the full surface. That surface 3 I did delete some break lines, so I'd rather work with the intact NGL. Okay, extracting them, select entities, that's the left road edge. And then the right road edge, also going to hide it from the NGL. And select the right road edge. Right click extract string. Okay. So you can see over here in the extract strings tab, over here in the control center, I'll just pin that open. Okay, when you see these extract string items in red, it means the road needs to be recalculated. So I'm going to run it from alignment, road, recalculate. So I still need to generate vertical alignment levels, the edge levels, and apply the road template. Okay, so there the road is recalculated. Let's have a look at those cross sections. So you can see from the cross sections that we've pretty much duplicated or mimicked what is happening on the existing road. The road edges and the vertical alignment are sitting on top of the survey of the existing road. Okay, so at this stage, the client noticed some flat spots. So let me just go to my shading quickly. I just want to show you The road shading, this drainage, remember you can set a flat slope tolerance which shows up with these red triangles, the flat spots. So the client then noticed especially on this second section of the road, that there were quite a few flat spots up here which needed to be addressed. Okay. And that required the vertical alignment to be adjusted. So I'm going to import that adjusted vertical alignment to show you what those implications were. So just reading in the CSV file. Okay, so they made some adjustments on this top section. You can see the road's a bit higher just to remove those flat spots on the road. Okay, so I'm just going to go back to my road expert and enable it again just so we can see the actual cross sections, the design cross section. Okay, so let's have a look at those cross sections now. So this was the issue now, is we've changed the vertical alignment, but our road edges are still linked to the CAD road edges, and they are still being interpolated on the ground. So the first section of the road, that was fine, but the second section where the vertical alignment has been changed needed to be updated. Okay, let's just have a look at that front section, the front section over here. If we look at this section of the road, we're still happy. Nothing really needs to be changed over there. So it's basically from chainage 2900 where the vertical alignment has been changed. And then we're having issues like this. Okay, so to fix this, we're going to use a combination of the two extract methods. Okay, so firstly I'm going to use alignment, regression extract alignments, and this would be to pick up the road edges from CAD. So we're going to use those two polylines that I created, and this then populates the edge level spreadsheet. Let's just have a look at that before I do it. If you look at the widths tab over here, currently we've just got the 3.7 meters, which comes from the road template that we're using. Okay, so we want to pick up from the CAD with all those little widenings, etc., from the survey of the road. So we're going to use alignment, regression, extract alignments, and road edges from CAD. Okay, so I need to select CAD again. The right edge. Okay, so if we look at that edge levels now, if you look at the widths tab, you can see. So using that extract strings and the road edges from CAD would populate the edge levels. So we're happy with that. But if we look at our cross sections now, go to that chainage 2900. Okay, so basically we've applied the normal crossfall, this camber condition, to the whole road currently. Okay, but on that first section of the road, let's go chainage 200. We've also applied the 2%. So now we need to remove these crossfalls up to chainage 2900. So we want to pick up the levels again from the surveyed surface up to chainage 2900. Okay, so the way we can do that now is we're going to go to alignment and regression and extract strings. Okay, so we're doing left and right edge string, but we're only going to use this method up to chainage 2900. I think it's 2920. Okay, so left, have to select the line again, extract string, and the same, just be careful there with the chainage for the right load edge, also still interpolating on the DTM surface. Okay, so let's have a look at those cross sections now. So once again, this is now picking up on the survey, so that would be fine. And then if I go to that chainage 2900, so from 2930 onwards now we're using that new vertical alignment where the changes were made, and we just applying the normal crossfall from the road template. Okay, so we used a combination of those two extract methods, the extract alignments and the extract strings. So that's all we have time for today. Until next time, cheers from me, and back to you, Charles.
Thank you very much, Andrew. That was very interesting. We will shortly be posting a video copy of today's webinar on our website's webinar page, which I showed earlier today. And by around midday on Monday, we would have posted the FAQ videos created from today's session on the website's FAQ library page. Once again, thank you very much for allowing the time to join us today. Please follow our company page on LinkedIn if you have not done so already, where we post our latest customers' civil designer software project showcase stories, relevant industry news, and new civil designer tech tip videos. Once again, thank you very much for allowing the time to join us today. Have a great afternoon, weekend when it arrives, and goodbye for now.